In this lesson, we're going to look at scaling, adding, and subtracting vectors. So scaling a vector means changing its length by a particular scale factor. So if we have a vector here of length a, then the vector 2a is going to have the same direction but twice the length. The vector 1/2 a has the same direction and half the length. The vector minus a has the same length, but it's in the opposite direction. So we can multiply a vector by a positive or a negative number. But multiplying it by a negative reverses its direction. The next thing we want to look at is how we add vectors. So the idea is that if we think of a vector as displacement, we have this displacement here from the tail of A to the head of A. If we add on the displacement of B, basically what we're saying is let's stick the tail of B at the head of A and see how far do we get going from the tail of A to the head of B. And that's basically the total displacement, right? Because we started here, we ended up here. So the total displacement, if we add together these two vectors, is this A plus B. This black vector represents A plus B from the tail of A to the head of B. Another way of that's talked about is with the parallelogram law. It's called, if we can take these vectors A and B and make a parallelogram out of them, right? We know all the B vectors, wherever we put them in space instead of the same vector, they're going to be parallel to each other because they're in the same direction and they're the same length. So we know we can make a parallelogram like this. And if we draw a vector from the place where the two tails come together to the place where the two heads come together, so it's one of the diagonals of the parallelogram, that's our vector A plus B. And you can see here again we have the this displacement of A followed by the displacement of B. But what's nice about the parallelogram law is it shows you that you get exactly the same displacement if you go along the vector B first and then vector A. So A plus B is equal to B plus A in vectors. Addition of vectors is commutative. So that's nice. And then let's take a look at subtraction. So there's a couple of ways we can think about subtraction. One of them is, if we think about it, if we have a vector that's length is A minus B, well, if we add B to that vector, B plus A minus B, that the B's should cancel and we should just end up with vector A. So that's one way to subtract vectors is to put the tails together and draw a vector that starts, if we want to do A minus B, draw a vector that starts from the head of B and goes to the head of A, and that's our A minus B. That's one way to think about it. Another way that might be a little easier to think about it actually is if we think of it as A plus a negative B. So I have, if this vector is B, then this vector, same length, opposite direction, is minus B. So we can just add together A plus negative B, right? And that would give us A minus B also. And we can see these two A minus B's are the same vector, right? So that's scaling, addition, and subtraction of vectors.